My name is Chris, and I'm currently a tech and team lead at a company called Vetspire. At Vetspire, we're building an electronic health record and practice management platform for veterinarians. Generally speaking, it's a software as a service that practically runs every facet of veterinary practice, from storing medical records, handling intra-practice and client-facing communications, scheduling, billing, inventory, pretty much everything. So with that out of the way, before jumping into the talk proper, I just want to break the ice a little bit, and I want to start with the game. So I'll share two statements about myself, one true and one false. And I'll leave it up to you guys to decide which one is true or which one is false. So one, I really like spicy food, like inhumanely spicy. I also have a tendency to get into the rabbit hole a little bit, so sorry about this. But at university, my fiance's sister was living with us, and she has zero spice tolerance. So not only would she never eat my cooking, she also needed her own cutlery and plates and bowls and whatever to mitigate the risk of cross-contamination. Two, I am a comfortable and confident public speaker. So, okay, that was fun. Great. I feel better now, thank you. So, on to the point. This talk is titled Easy Ergonomic Telemetry in Production with Sibyl. So it goes without saying that I'm going to be talking about something called Sibyl, and that it relates to this nebulous thing called telemetry. So just to give you all a TLDR, Sibyl is an open source project that we're releasing at Vetspire, and it's a collection of related tooling that aims to integrate with and augment how you can capture and utilize standard telemetry in your Elixir applications. Sibyl's main goal is to make it as stupid simple to capture telemetry, so easy and thoughtless that it just becomes the norm. It just becomes a default for your engineering process. While this talk isn't really about the ins and outs of telemetry itself, I will go into it a little bit to just establish some common language. But before that, I just wanted to share the general outline of the talk so we kind of know what to expect. First, I'll share some context around why we bootstrap Sibyl. Then I'll give you a sneak peek into what telemetry looks like in Vetspire itself. Then we'll talk about the wider standard landscape as far as Elixir is concerned in telemetry to just establish a baseline, before finally talking about what Sibyl brings to the table and why we think it's core. So, as I said, Vetspire is a pretty small company. I didn't actually say that. On the engineering side, I think we have 13 engineers at the moment working across two teams. The team I lead is the data and insights team, and we own several of Vetspire's domains, such as all of our financial logic, all of our reports, analytics, and what I'm going to be talking about in this talk, our medical reminder subsystem. Our medical reminder subsystem handles a reasonable amount of traffic. We sent out, I think, 1.5 million SMSs, postcards, or emails in the last quarter. And knowing what reminders need to be sent for any given patient, when, where, that's actually a non-trivial problem. Our medical reminders are powered by a subsystem that we've called protocols, and they're made up of a series of different stages, which are modules that implement one of our macros called protocol stage. On the screen, you can see what a stage generally looks like. Protocol reminders can be triggered, sent, invalidated, have their due dates changed, have the content of the reminders changed based on the creation, the ordering, the deletion, the modification of practically any entity in our database. So there's a lot of flux and a lot of complexity here. And our abstraction is that each stage represents a step in determining if a given patient should get a reminder. Each stage explicitly defines inputs, outputs, and a callback that lets us effectively incrementally regenerate a materialized view. Not super important. It's just complex, right? And we massively run these stages asynchronously to quantize the amount of data we need to look at to determine what reminders actually need to go out when. Each stage effectively shrinks the amount of data that needs to be considered by subsequent stages. Again, going into the complexities of kind of what we're working with and the scale, the protocols engine reflects on all of the defined stages and uses the digraph module to build a dependency tree. The stages returned here need to be materialized from head to tail, but we do some smart stuff like determining, okay, here we need to materialize the patient stage, but then we can actually materialize the next couple of stages in parallel because they have no intradependencies. And as a side effect of our terminal stages, what we do is we actually schedule some OBAN jobs to go out to actually talk to Twilio or SendGrid or whatever else. It's run once a day for every location that uses Vetspire, so a few hundred. Each one of those have sizable medical histories going back decades. And using OBAN workflows, this is what effectively powers our daily reminder sending in a resilient and scalable manner. But it can also be run on demand whenever a veterinarian just looks up a patient's chart and just needs that information right here, right now. So we have a task async await executor as well, and it basically works the same way but gives you the results immediately for a single patient. This kind of thing is very complex. There are a lot of moving parts. It's extremely performance sensitive because we need to make sure our reminders go out at the right time. And honestly, it's not the easiest thing to grok for people who are unfamiliar with this, especially if you're new to Elixir. So from the get-go, we had some concerns about the observability and just like the understandability of the protocols engine. Before joining Vetspire, I had the opportunity to work as a consultant with Erlang Solutions, and during that time, I managed to work on a lot of different projects of all shapes and sizes, and time again on each project, we'd eventually get to this nebulous point of the software development cycle where we'd start having to think about answering some tough questions, right? So, for example, here, how can I better understand complex flows, right? That's a simple question. But also, like, how do we discover and prioritize what parts of an application need to be optimized? What would be the impact of deleting those gnarly APIs we deprecated years ago? How many people are actually using the features we build? Or how is our non-user API traffic affecting real-world users of our website? Generally, in each case, we'd eventually conclude that we needed to look into, implement, and investigate this thing called telemetry, and we would add it to our projects. And thanks to the various times I've seen telemetry get added and the few times I've managed to jump in and roll it out myself, when this time came at Vetspire and we started to have these concerns, I kind of had an idea of like the configuration ceremony I'd have to do. I knew about a few of the foot guns and annoyances that would likely hit too. So I built Sibyl. So earlier I said that Sibyl is as stupid simple as possible to maximize ease of use and ergonomics. And we'll get into particulars a bit later. But the TLDR is you add this single line to your application start callback to kind of tell Sibyl to initialize and just listen to stuff being emitted by your application. And any modules or functions you actually care about capturing telemetry for can be instrumented with as few as these two lines. And this is it. This is telemetry in Vetspire. And that gives us a couple of fancy graphs which tell us very basic things like the number of times functions are called, how long they take to run, error distribution. In more detail, you can see when functions are actually implemented, executed. I think this screenshot actually shows us the protocol API that I showed running and generating reminders, and you can kind of see the spikes in execution where we're scheduling jobs thrown at certain times, and it's pretty tight, so like that's pretty good. That gives you an idea of the health of your system. And record at protocols runs either like massively distributed across our cluster via OBAN or via a single node using task async await. And what's cool is we can have a single place, a single source of truth to check to see how long the entire process takes. Each horizontal bar here is a function execution, potentially asynchronously, that's been stitched together. And if any of them take very long or fail, we can just click into it and kind of see, okay, what arguments were put into it. And from then, that gives you a step to like try debugging it or trying to understand what kind of failure mechanisms we have. So that's cool. You can do a bunch more stuff that we don't really do at Vetspire, but you can build dashboards and graphs and have like alerts and stuff defined based on whatever kind of downstream service you're already using to track your observability stuff. And we'll dive into that a little bit later, even though it's not so much about Elixir. But I've said the word telemetry literally 14 times already. So without further pitching, selling, whatever, what the heck is this telemetry thing? I think it's important that we have some common language to talk about. So to be a cliche, the Oxford Dictionary defines telemetry thusly. It's the process of recording and transmitting the readings of an instrument. And if we apply that pretty much verbatim to our software engineering context, you essentially get the right high-level idea, right? It's the process of recording and transmitting metadata emitted by your applications, from which you can then go on and use that metadata to derive knowledge and insight about your applications. And amazingly, in the Erlang and Elixir ecosystem, we do have this de facto standard library for doing all of this, unsurprisingly called telemetry. Now, being a standard of sorts, I'd wager if you're not already using telemetry in your applications, every engineer in the room already has a heap of it sitting around not doing very much. In fact, outside of the telemetry we capture ourselves using Sibyl at Vetspire, we heavily utilize libraries such as AbSim for OBAN or Phoenix, and we do make use of the telemetry being emitted by them. Other dependencies you use, such as Finch, Tesla, literally anything else that comes to mind, also emit telemetry events. So if you're going to take any one thing away from this talk, like, yeah, we built a thing, we think it's cool, we use it, we think a lot of people might be able to get a lot of use out of it. But I'd take away the fact that this thing called telemetry exists. It's already being emitted in your applications, and I guarantee, if not now, at some nebulous point in time, you guys will come to the conclusion that there are these difficult questions that you want to start thinking about and pondering about. And I think one important avenue to look into is, like, can you answer or can you direct your engineering process using the telemetry events that already exist in your system? Like, there's a lot of information there just waiting to be used. But anyway, so now we have a high-level definition of what telemetry is, and we've defined that there's a library that everyone in the Elixir community uses. That's great. So given that, how do we actually use telemetry then? So this will be a whirlwind tour of telemetry itself and the surrounding landscape, and I'm going to move a bit quickly, so apologies for that. The telemetry library gives you access to this telemetry execute free function. This is the fundamental singular thing you really need to use as a framework or library author to start emitting telemetry events in business logic. When called, what we're doing is we're emitting an event with a given name, measurement, and metadata, and that's literally all a telemetry event is. The name is a list of atoms that uniquely identifies any given event, and conventionally, every event emitted with a given name should have that same static shape for their measurements and metadata so that you can do useful things with them down the line. Measurements are numeric data related to your event, so in Vetspire we might have an event called appointment started, and maybe some measurements associated with that might be how late the appointment started, or how many patients are part of that one appointment. Metadata is other stuff, unsurprisingly. Generally, you can use it to enrich your event or to help tag the event. So hypothetically, you might store the hospital ID or the doctor ID that pertain to the appointment. Now, it's important to note that these events are very simple, and they're completely discrete and decoupled from everything else in your system. So alone, they can only tell you basic facts about your system. But there are conventions you can use to effectively derive higher order information from your event, generally by looking at multiple related events in tandem. So for example, per my hypothetical, if we capture an appointment start event, okay, that's great, but if you can compare it to the number of appointment canceled events, or the appointment late events, or appointment missed events, you might be able to start deriving statistics such as attrition rate, or how busy is a single hospital or doctor. Really, it's up to you. The most common example of this higher order telemetry stuff is this example I plucked from Phoenix. So basically, if you emit a telemetry event at the beginning of your function and the end of your function with timestamps on both sides, that's cool, right? So from that, you get the delta, and you can figure out how long your functions take to execute. You need to take care to handle errors and exceptions and throws and exits and whatnot, but you can do it pretty easily. Literally, it's just what's on the slide. But it's common enough of a convention that telemetry gives you this telemetry span free function, which basically automatically wraps the given closure with the same start-stop exception telemetry events that you saw on the slide, which is really cool. As a framework or library author, I'm going to posit that if you want to implement telemetry, this is as far as you really need to go, right? Pepper these function calls into your code base, expose all of the metadata, and your job is done, right? But as application developers, that means that you have applications rich with telemetry, but you're not actually doing anything with it. So there's one last thing we've got to look at. The telemetry library also gives you access to various functions to make use of your telemetry. They're all more or less the same. So for example, I'm just going to talk about this telemetry attach many for call. So this screenshot literally says, please execute the given module.handle event for callback whenever one of these many events we care about are being emitted in our system. Telemetry handlers are very cool because they're just like an RD4 callback that gets run inline, synchronously, wherever the events you listed are emitted, be it your own code or even library code. You can do some really cursed things with this. I think the most cursed thing I've ever built doing this is hooking into Ecto's telemetry events to build an audit log system, just completely transparently on top of all of my repo inserts and updates. It's a really bad idea, but it's possible. I think at Vetspire, though, we actually do hook into Oban's telemetry per its documentation to send Slack alerts to our team if jobs fail. Generally speaking, though, another assumption I'm going to make is that your company probably already uses a tool for observability elsewhere. You might be using Prometheus or Kibana or whatever else. For example, Vetspire personally has been using New Relic since the beginning, I guess, since very early on, since before I joined. And I'm even wearing New Relic socks today, so that's cool. Anyway, my experience has been that outside of any ad hoc handling of telemetry events you want to do, which you review on a case-by-case basis and you do you probably just want to shuttle all of your telemetry events downstream to whatever observability platform you're already paying for. That gives you the advantage of being able to use their bespoke tooling to really build enriched dashboards and graphs and whatever else you want. Thanks to the ubiquity of telemetry in the community, that's great. You can just pick up one of these various telemetry handler implementations straight from HexPM for all sorts of stuff like StatsD, Prometheus, CloudWatch. There are loads. Just search telemetry in HexPM and that's great. Add that to your project. Use that provided library's handle event function when attaching your events and profit. It's all hooked up. It's all done. Now, as I stated, I'm wearing New Relic socks, and in the past, as a consultant, I built a very similar system for a company which was heavily invested in Datadog, Grafana, Kibana, and that was their stack. And Vetspire is a very Elixir-based company on the backend side of things, but this particular client at the time wasn't, and they were already using a lot of infrastructure for observability in their Java and Ruby applications. So at the time, they introduced me to this thing called OpenTelemetry, and it's super cool. So if you haven't gotten sick of me saying the word telemetry, well, there's a little bit more, so apologies for that. But what if you didn't need to fetch specific handlers for specific platforms to listen to the specific events in your system? Well, OpenTelemetry gets you pretty close. OpenTelemetry is a collection of standards, APIs, SDKs, and tools that help you capture and export telemetry data downstream to a whole bunch of existing platforms, New Relic being one of them. OpenTelemetry concerns itself with logs, which I'm not going to speak about because we just use the standard Elixir logger and rely on existing Unix and Kubernetes tooling to search through them. Metrics, again, these map pretty tightly to the discrete events that get emitted via telemetry execute free, so a bit boring. But traces, this is the cool stuff. A trace is basically just a telemetry span free, but you get support for distributed tracing too. So spans in plain old telemetry land are, again, still pretty discrete, and you have to do your work up front in your handlers to kind of figure out nesting if that's something you want. Distributed tracing is kind of built into OpenTelemetry, and it not only supports things like nesting by default, you can also stitch traces across process boundaries, across APIs, across nodes, and even across languages. So you really can have a single source of truth for some kind of action in your system. In our case, we're talking about the protocol generation, which again is a very complex asynchronous workflow with multiple execution modes. To get started with OpenTelemetry, just pull in these two libraries at minimum, and you get access to some macros. You use those macros to annotate and trace your functions, and you're done. The OpenTelemetry landscape and telemetry landscape on the Beam feel like two parallel things because that's because they largely are. There are some helper libraries okay, bear with me, OpenTelemetry Actor, OpenTelemetry Phoenix, OpenTelemetry Telemetry, whatever else. Those libraries help bridge the gap between the Beam's de facto telemetry library and OpenTelemetry, or you can go and try to build a system that bridges the two together yourself because it's not that difficult. And once you get everything set up, despite being a bit of a DIY project, it does work really, really well. So back to the main point of all of this, right? Now we have a high-level understanding of the telemetry library, how you instrument your code, how you attach event handlers, and how you might want to ship stuff downstream. And we know that OpenTelemetry is a cool kind of platform-agnostic standard, which feels pretty close to something we could utilize in the generic sense. This is a lot of moving parts, especially if you've never heard of any of this stuff before, or especially if you're new to Elixir. But it's not really that complex, right? Like, any of our dev teams could probably hand-roll something that generally works. You trace functions, you add spans to your code, you execute events, you build your own handler, and you're done. So how does Sibyl improve and make this stuff easier and more ergonomic? Well, we'll step into the features that Sibyl brings to the table and talk about the paper cuts, which I've kind of left in the air implicitly. So the first thing and the lowest level feature that Sibyl gives you is the fact that telemetry events have compile time guarantees about them. When you use Sibyl in your code, you get access to an alternative API for emitting events called sibyl.events.emit free. It's also auto-imported into your modules, so you can just use emit in this case. The emit macro does exactly what telemetry execute free does, but before emitting any telemetry event, Sibyl is able to check to make sure that telemetry event has been defined beforehand. If we read the code on the slides now, you can see that we're defining valid event on line 11, sorry, them relative bindings, and we emitted on line 3. But does this code compile? This might be a little hard to read, but no, it won't compile. We also tried to emit an event called example event, and per the error message here, no such event was defined in that module. The underlying telemetry library is very minimal, language agnostic with respect to like Erlang, Elixir, Gleam, whatever else, and it's designed to be, right? Like it's not a downside or limitation of telemetry itself. But using the underlying telemetry library, you can emit whatever you want. If you really wanted to, you could emit events that belong to your dependencies as though they were your own. There's no kind of ownership there. And realistically, we've found that telemetry event names usually pertain to their surrounding code, their surrounding context. Spans are usually named coupled to their modules and functions. Like documentation, care needs to be taken when building new code, moving code, deleting code, to make sure that all of the telemetry instrumentation you've done is updated accordingly. Your system can start emitting completely new events, and you need to make sure whenever new events are introduced that you handle them appropriately. When you rename events or you delete events in your business logic, you don't get any kind of feedback for trying to attach to them still. This sounds fine, right? Like it's not necessarily a runtime failure that an event doesn't get emitted ever. But if you've built complex monitoring and alerting based on the assumption that these things exist, them just silently disappearing under your feet, you're not going to run into an issue until your alerting doesn't alert you that something is seriously wrong with your runtime systems. Out of the box, you just don't get any feedback. If you're double instrumenting your code with telemetry and OpenTelemetry, you've just got double the surface area for mistakes to be made. Because Sibyl tracks what events are defined at any given time, Sibyl also provides APIs to reflect on what events are defined in a single module or a single application or are loaded in the VM entirely. And because of this, you don't need to tell Sibyl what events you care about in your system when attaching. You just tell Sibyl to attach everything you've defined. Building on top of this compile time stuff, Sibyl also provides features to auto-instrument your code for you. When you use Sibyl in your modules, you get access to this @decorate or @decorate_all module annotation, which comes from a great library by a guy called Arjan. It's called Decorator, surprisingly. But when used, these can automatically decorate every function in a given module or the preceding function. Sibyl provides this trace decorator, which automatically does what telemetry span does. It goes in, takes your code, and automatically instruments it with start, stop, and exception events. Almost all of the telemetry we use and capture at Vetspire comes from these single lines, which are just peppered in our modules wherever we think it's going to be important. Like if you look at these screenshots, this is actually what I showed in the beginning of the talk. And when I was running through the protocols engine, this single line at the top of our function head is what gave us those distributed traces in New Relic. Now, I don't know if you can read this code in great detail, But this is the exact same function. The darkened section is the business logic on this slide. It's the same darkened code. Every other line here is just telemetry instrumentation for emitting events. We've got to wrap the stuff we care about inside a try, catch, rescue after, make sure we emit events appropriately, consistently. Everything's like way more indented now. It's very long, and honestly, like if you're skimming complex code, right, I'm not going to know what that actually does without really reading it. Sibyl's auto instrumentation decouples the act of capturing telemetry from your business logic itself. You get all of the benefits of capturing telemetry, and you get all of the benefits of not adding any additional line noise to your functions. As an aside, Sibyl doesn't use telemetry span free internally, which requires you to wrap your code in a closure. Because we are a macro, we can just take the function body that you've decorated and compile into it discrete telemetry execute events. I've not done any benchmarking on this, but I'm pretty sure I've read that anonymous function execution is an order of magnitude slower on the beam, so you really don't want to be using telemetry span all over the place. But this gets us pretty close to a zero-cost abstraction. The last of the core features of Sibyl is that we provide a couple of handlers out of the box. When we started developing Sibyl, we did what everyone does when you do your first telemetry thing, and we built a logger handler. So any telemetry events just kind of get written to the standard log. So that's Sibyl handlers logger. Now, this wasn't really useful outside of just demonstrations until yesterday. When we saw in Chris McCord's keynote, with the new live view releases, we're able to send logger logs down to our web browser's console. So actually, I think I heard someone ask a question related to like getting to telemetry in the console as well, and this just kind of works. Like assuming that you can just send your logs directly to your web console, your live view development experience is literally just clicking around, and you can see all of those telemetry traces in line. So that's potentially very powerful. After we built that, we actually built this flame graph handler, which stitches telemetry events into a JSON file for local debugging. You can use Google Chrome's internal flame graph stuff, or you can use applications such as Speedscope to render them and really delve into them. And all of that stuff works. And it's cool, and like it's great, it's tested. It's a good like learning opportunity for if you want to implement your own handlers. But then we built our OpenTelemetry handler, and that's pretty much all we use now. The OpenTelemetry handler transparently translates any telemetry events that are attached to it into something OpenTelemetry compatible. So we've really bridged the gap between generic telemetry events and just getting that stuff downstream into a platform that you already use and you invest in. And we also augment those traces with a bunch of metadata, so you can tell what arguments are being passed into any of your functions and what arguments are coming out, which really aid in the debugging story. One of the cool things about the ubiquity of OpenTelemetry is that it's everywhere. Loads of different services use it. And Sibyl comes with an example Docker Compose file, which allows you to bootstrap a service called Jaeger. Jaeger is a OpenTelemetry compatible distributed trace viewer. So even if you're not using an observability platform in production, you can get the same kind of benefits for local development. Here you can see a few traces emitted by my localhost instance of Vetspire, and you get all of the same kind of information. You get all of the same distributed trace viewing. You can see all of the metadata that we capture and ship to like New Relic proper. This is a real Arity21 function at Vetspire. We have a few of these from the early days. Debugging these can be really annoying because a lot of the arguments are like implicitly nils, or like they default to something random. At least with Sibyl, we can just copy and paste the arguments, so we don't need to worry too much about it. That helps. It justifies us not refactoring this stuff sooner. Now, this one's a freebie, because I wasn't sure if I'd have enough time, and I didn't start my clock, but I'm going to go until someone tells me to stop. So Sibyl does a lot of stuff on its own in terms of owning and emitting its own events and attaching to its own events. But telemetry is a BEAM standard, so we're actually building a first-class plugin API. You can see here that actually in Vetspire, we have this Absinthe plugin. So we serve a Absinthe API, which our web app is built on top of, but we've also got clients who have built entire mobile apps and other integrations on top of our API. So being able to have the Sibyl plugins Absinthe thing just boot up, that enriches our traces with all of the queries that happen, what arguments go into queries, Each one of these kind of like tiny rectangular blocks is like a sub-resolver, so like field resolution, your batch functions, your data loader, like all of that just for free with one line of code. So that's kind of what I'm getting at when I'm talking about easy and ergonomic. I don't want engineers on my team to necessarily think about capturing telemetry. It should be the default. It is close to a zero-cost abstraction, and you never know when you might need to debug something. Last but not least, and most interesting, this is an alpha feature that we're working on called Sibyl Dynamic. One of the benefits of being a layer built on top of telemetry and on top of all of these other libraries, because you could just hand roll this yourself, it's really not that hard, is that we're not really coupled to anything, so we can do all sorts of crazy stuff. So the BEAM already has a bunch of arcane functions that you can use to tell the VM to trace anything that happens in your system. So Sibyl Dynamic allows you to start a process with a Sibyl handler of your choice. And again, for maximum utility, we're just going to use the OpenTelemetry one so that you guys can see all the great visualizations. And you can tell Sibyl to do something like trace enum map 2. Internally, Sibyl is doing a bunch of low-level debug calls. So the BEAM is now going to watch for every single execution of enum map 2 in your system. You can trace individual functions, or we're working on an integration using Xref to analyze your call graph of a given function. So you can say, hey, I want to trace, I don't know, myapp.users.create to like a depth of 5. And you just get all of those functions, throw that into the tracer. And the next time those functions are run, we keep track of a call stack, piece stuff together. And once everything is over, what we do is we essentially emit fake events in that tracer process, calling into our handlers in a way that looks like a normal telemetry execute. So what that gives you is complete observability of your system, not just with instrumentation, not just with auto instrumentation, but with no instrumentation, provided you're okay to have your nodes crash if you trace too much stuff. Sibyl not only makes it easy and ergonomic to start instrumenting your code, but it gives you an escape hatch if an outage is being caused or some performance issues are being raised in code that you've not even thought was mission critical. There are a lot of caveats and rough edges, but I think this is really the thing I'm most excited about in terms of Sibyl. But I think with the instrumentation and the compile time checks and just like the safety and validation, Sibyl brings a lot to the table. We've written a lot of docs on Sibyl, so if you're interested, there's that. And there are also a bunch of rough edges, I'm sure, because right now we've got several different mixed releases. Everything's running Sibyl, but really it's a Vetspire exclusive thing. But I'd like to see what you all think. Thank you. That's my talk.